We've got one more quick topic to cover this week: how to define our own interface types. The term interfaces refers to messages, services, and actions. While many useful interface types are provided by different ROS packages, many ROS projects end up needing to define their own interface types. Luckily, this is pretty easy to do. It's best to define your interfaces in their own package. Most of these package names either end with _messages or _interfaces. I've added a new package next to our RJ training package called RJ Training Messages. This package has the same structure as all the other packages we've seen so far: a manifest file called package.xml, a build file called cmakelist.txt, but now instead of C++ source code, we have 3 folders for different kinds of interfaces: a folder for our action types, a folder for our message types, and a folder for our services types. I've created one example message here called fortunecookie.msg. In our package manifest, we need to declare 2 dependencies for this package. At build time, we're going to need the Ros Idl Default Generators package. This includes all the tools we need to convert our interface files into generated Python and C++ code. Then at execution or runtime, we'll need the Ros Idl Default Runtime. This includes all the libraries and support resources we'll need to use our messages at runtime. Finally, we need another tag here called member of group. This is going to register our package name as a member of the Ros Idl Interface Packages group. This is a group that other tools will reference when they need to figure out what packages offer new interface types throughout the ROS system we have installed. Over in our build file, we're pulling in the Ros Idl Default Generators package that we'll need to actually do the code generation. That package provides us with this function Ros Idl Generate Interfaces. We give it a target name, which needs to be the package name, and then we give it the list of source files we want to compile. In this case, we've just got the one fortune cookie message file. Then we need to give it a list of dependencies. These are the names of other packages that define interface types that we are using as fields in our interface types. In this case, our types don't depend on any other packages. They just use the standard types available to everyone. So our dependencies list here is empty. Finally, we have the add Linter Test flag, which will add various style checking tests for our interface files. The Generate Interfaces function will create C++ and Python code for the interface types we give it. This creates a new target and all the associated rules needed to build that target. The last thing we need to do in our build file is export a dependency from this package to the default runtime. This ensures that any other packages that depend on our package will also indirectly pull in the default runtime package, which they'll need to use our interface types. And finally, in our actual message definition file, we have a pretty standard message definition. Each line is a field with the type of the field and the name of the field. These interface source files contain exactly the kind of text we've been looking at when we were inspecting other interface types, such as messages and services, in previous videos. Now, once we build our workspace and source our overlay setup script again, we can use our fortune cookie message type with any ROS tools. To demonstrate, I can run a topic publish command that will publish a new fortune cookie message onto the fortunes topic, and then in the other terminal I'll run an echo command to see that message come across that topic. We see our fortune cookie messages coming through, so we know that ROS now has access to our custom message type. That's all it takes to add custom interface types, and that's it for this week of ROS videos. I'll see you next time.